Well, it's the last session for today, so I'm glad that there are, well, I hope there are so many of you because I don't see anything because of lights. So let's get it started. My name is Grzegorz Piwowarek. I come from Poland, and basically I work as a software developer in a software house in Poland, Toke. And besides this, I'm a retired professional Yoyo player. Yes, this is a thing. I'm also a musician in like bands that basically only other musicians listen to. Okay, if you really want to find me anywhere, there is the only one Twitter handle. It works pretty much everywhere. Okay, so before we jump straight into the main session, how many of you have been today to Oleg Shelayev's talk about functional data structures? Okay, I don't see anything because of lights, so I'm just assuming that everyone just raised their hand. Okay, so if you enjoyed this, there will be much more functional goodies coming from here. He was talking only about one very big topic about functional data structures, but obviously there are much more things that can be brought to Java to make it more functional. Okay, so a few years ago, in 2014, there was a Java 8 release, which was, well, pretty spectacular, okay? Because suddenly, after so many years of pure OOP, Java 8 was getting lambda expressions and some other tools that were known from the world of functional programming. And it was something special, okay? Some people hated it, some loved it, but anyway, everyone anticipated it. So yeah, it was supposed to be something really special, something very good. And many people were actually even saying that the Java 8 is functional now. Well, but if you have a deeper look, you can see that the functionness of Java 8 is lambda expressions and, well, tools like optional streams, completable features, and not really much else, okay? So actually some people over there, they were claiming that even the functional aspect, the aspect of those tools that were introduced, well, it wasn't perfect, okay? People started making jokes that it has too much boilerplate, and the whole functional aspect of Java is just writing code like this, like using streams for basically querying simple filtering of stuff. So after some time, people started noticing stuff. So first thing, why only 3 functional control structures? When I'm saying functional control structures, I mean stuff like optional, stream, future, completable future, because tools like Scala, they have much more. Okay, there is try, either, validation, lazy, and some other stuff. Why not bring this stuff too in Java if you are bringing some functional tools already? There was no concept of memoization introduced. Don't worry if you don't know what it is. We are getting straight into this. There was no lifting on functions and functional interfaces. We are getting to this. No pattern matching, which is very common tool used in functional languages like Haskell, Lisp, Scala. No tuples, okay? After so many years, we still need to write our own tuples or just use one of billion GitHub projects that contains tuples. Well, for some reason, it's still not here. And even the design of some classes that were introduced, like optional, for some reason, they were not made serializable and iterable. And guys from Java, they have very good explanation for this. Well, the explanation goes something like, well, it was not intended to be. Well, I don't really buy this because it's not that problematic. But let's say that, well, it's a good explanation after all, you can't deny it. The biggest problem for me was that, of course, Java needs to be backwards compatible. All new releases needs to be backwards compatible. So if we had like APIs, old APIs, they still need to stay there, and we can only add new ones. And this is problematic because now we are mixing few different approaches together, and there is no one convention along the code, and it becomes problematic, okay? Because we might mess something. Another thing is when people started playing with functions, lambda expressions, they notice that if you encounter a checked exception in a lambda's body, it's super painful because for some reason you need to manually try and catch it and basically just swipe it under the carpet or just repackage into an unchecked exception. It happens because all those functional interfaces that were introduced in Java 8, they don't have a throws clause in the method that represents the lambda's body. Well, it's problematic because if you have like a very long stream of operations, a long chain of operations, and let's say that you're using some external library for modifying something in there, and some of those methods throw checked exceptions, the code becomes ugly, okay? Because suddenly we are try-catching everything. But the real thing is that we are only worried about the fact if there is exception or not. But yeah, we need to try-catch n exceptions in the worst case. Also, there's something like type pollution. What it is, people started having problems with the fact that you have so many names for functions in Java 8. There were introduced functional interfaces. The basic one was called function, but there were different specializations of it. So you had function by function, predicate by predicate, consumer by consumer, unary operator, binary operator, and specializations for some other stuff, okay? It was really problematic, okay, because if you were browsing new APIs, you were encountering a lot of new words, and it was hard to process. And obviously, even some very simple operations could have been done in a much easier way, okay? Because such simple operation as mapping elements in a stream still contains a lot of boilerplate code that could not be there. Well, probably the list could be much longer. Let's go further. So before we jump straight into Javaslang and we'll see what Javaslang gives you, let's have a look at this simple signature, okay? So the name is not very meaningful. We have a list of inputs, there's an output, a return value, of course. And since there is a list on the input and list on the output, we probably we've been coding a lot. So probably we have some kind of intuition about what can be done inside it, okay? Let's have a look for it for a second, okay? And now I actually bothered to implement it. Let's see what's inside. Okay, so I bet you didn't expect this. Okay, so what's happening over there, I tried to put a lot of bad practices into implementation of this class. So you can see there that we are modifying some inner state of the object. We are modifying some external state. We are modifying params, throwing some unexpected exceptions, and pretty much taking some values from the outside world from the values that were not declared as inputs of this function, and also messing up pretty much everything around us. Well, and this can be problematic, okay? Because the reality is that when we are writing methods, even simple methods, we don't have only declared inputs and declared outputs, okay? Reality is that we still can have values, hidden inputs and hidden outputs, okay? So if there is like your instant state of your object for some reason influences the possible result of your function, of course this is a hidden input and should be considered like this. Same with a global state, okay? If this changes the possible output, it's an input. Same with outputs. Imagine a situation that when you mess up some internal state and this influences another results, it's a hidden input of another method, and this changes a mutable global state, which changes some other state, throws exceptions, okay? It becomes very, very cumbersome, very unclear. And imagine now what happens when we are trying to compose solutions with methods that have a lot of hidden inputs and outputs, okay? Suddenly at some point, this will just explode. And good luck with debugging this. So in functional programming, what we are often aiming for is a situation where when we are defining something, defining functions, we define them in a pure way, which means that when we have inputs and outputs, so there's only direct relationship between them, okay? So if we accept two parameters, those are the only things that can influence the output. So basically, in such case, we are building small, predictable blocks. And now, when we are composing our solutions from small and predictable blocks, well, usually it works more often than stuff that just has a lot of hidden stuff inside it. So here, I'd like to say one thing about that there's a common misconception, because if you go to some message boards and stuff, you can see many times that there are people discussing and basically assuming that what defines a functional programming language is the presence of lambda expressions. Well, it couldn't be further from the truth, because obviously lambda expressions is something nice to have in functional languages. Actually, it's all about being able to pass behavior some way. And guess what? We were still able to do this in previous Java releases, okay? Because if we wanted to start a thread, we still were able to provide it with an anonymous implementation of a class, of an interface, and it was working, okay? So it was still some kind of like cumbersome way of doing lambdas, but still it worked, okay? So actually, I found a really nice definition. There are many definitions about functional programming, but this one, what I want to focus on about during this talk, is the functional programming is about writing pure functions, about removing hidden inputs and outputs as far as you can, so that as much of our code as possible just describes a relationship between inputs and outputs. This is what describes those perfect small blocks that we will be using for composing solutions that just work eventually. So by having small blocks, predictable, we are hoping that stuff will work. But there is also what we need to say right now is that there are two very common concepts that are related to this, which is immutability and referential transparency. So obviously, when we have this direct relationship between inputs and outputs, but it wouldn't be very useful if we don't have a determinism, okay? That if we call a function with certain parameter and that the result of this call can change, okay? So being referential transparent is super important, which means basically is when we are calling the function with the same parameters, we always get predictable results. Well, not predictable, always the same, okay? This is super important. Super important is that we, after creating objects or functions, because in functional world, functions are objects too, those should be immutable and unchangeable, because in this way, we are making language, we are stripping language from many possibilities where we could make mistakes. And if we manage to build a solution that works out of it, well, it usually works. So another common misconception is that Mario is here. No. Okay, we can talk about him. So basically, there is this another misconception that functional programming is all about just throwing away, writing code without side effects, mutability. But actually, the world around us is there are side effects and mutability everywhere. So it's not about just getting rid of it, but we want to abstract things out. We want to encapsulate everything in such a way that we won't be dealing with direct problems that those things cause, okay? So let's start talking about actually how to implement this in everyday life. But it becomes problematic, okay? Because we know that functional programming exists without lambdas, like in Java 8. Well, there was a Guava after all with some functional concepts implemented. But it's really hard to do, to write functional code like this if we don't have right tools for this. And if you have a look at Java Collections API, well, it's one of the most important building blocks of Java, okay? It's all in all APIs, it's in external libraries. There are contracts that enforce you to pass instances of those interfaces. And they have methods like add, remove, clear. And if you look at what they return, they either return nothing, okay, or they return booleans or some other metadata that tell us if operation was successful or not. This is the problematic, because if we want to use immutability in the context of collections, well, we need to design them in a different way. Well, obviously we have something like immutable collections, immutable wrappers for collections in Java, But what happens when you call an add or remove method then? You get you get an exception, and this is not how you want to design it. So this is very problematic. Especially if you are dealing with such stuff, you sometimes need to deal with problems that usually would not be there. So for example, this is a very common problem. If you have a set and if you want to put some objects in there, and if you modify this object suddenly outside this set, we lose the identity of this. And good luck with debugging this, okay? Because about such stuff we might not be thinking consciously all the time when we are coding. So the Javaslang is basically an answer to all those problems. It provides the right tools for the job if you really want to start playing around with functional code. So what Javaslang is? Well, yeah, it's pretty complex structure, but at the end of the day, it's basically a set of new functional control structures, so tools like streams or stream optionals and so on, and the whole new redesigned collections API. This is fully persistent and immutable. So if you went to Oleg's talk now you know what it means. Also, we got like tuples finally, and a new set of functional interfaces that are, well, on steroids in comparison to what we got in Java 8. So basically there are 3 building blocks of Javaslang, and there are a few words of disclaimer. The Javaslang is going through small revolution. There will be small API changes. Those are now in alpha version. So now today I'll be covering the stable production version that anyone can use. Alpha is not stable yet. So the first thing. In Java 8, we had functional interfaces, but unfortunately, the arity of them was maximal 2. Arity means the number of parameters that were accepted. So if we encounter a situation where we had more than 2, well, we need to write another interface. The other thing was some non-intuitive names of functions. So what was introduced in Javaslang, there were created new interfaces in a very predictable manner, because there are names, okay? There is a function and there is a number in the name that signifies the arity of function. So everything is super predictable because we are representing everything by function, and if you know what arity you are looking for, it's quite easy, because if you're looking for 5 parameters, you're typing function 5, okay? But imagine what would happen if you follow the convention in Java 8, because there is function by function. Well, and that's all. But if you want to go further, it's like tri-function, quad function, quintuple. Well, my English just breaks down at this point. Anyway, let's go further. So those are just simple functional interfaces, but there were problems with check exceptions, as you remember. So for this special reason, we got a set of like another functional interfaces, which are, well, almost exactly the same like the one I talked right now, but they have those throws clause in the method of a functional interface. So if you ever want to use some kind of if you ever encounter some kind of checked exceptions in there, you can use checked functional interface, and you won't need to try and catch an exception. What's also super nice that you can compose them together, apply function composition to them. Well, this is actually the same thing that was available in Java 8, but besides this, we have also something like called function lifting. Because if you have a checked function, we are not always sure if we get a result or not, okay? There are certain combinations of parameters that might result in a situation where we get an exception. Well, which means there is no real value computed for this set of parameters. And lifting can change a checked function into normal function. We'll get to this in a second. There's also a carrying implemented, and memoization, which is my favorite thing over there. Let's see some examples. Okay, so when we are talking about lifting, I created here a function that throws, in this case, an unchecked exception when b is 0. And let's say that we want to lift it, okay? So make sure that it never throws exceptions. It's super easy because we have static helper method that allows us to achieve this. But what happened over there is you can see that the returned value changed, okay? Because in the first example we had an integer, but now we don't have a result for every for all combinations of parameters. So in this case, we can represent the result as an optional, as an option, okay? That which returns an optional with a calculated value if everything went correctly, and if there was exception, the option will be empty, okay? So in this case, we can avoid just having exceptions when thrown in lambdas. Another fun thing to do is carrying, which is basically changing a function of a higher arity than 1 into the function of arity of 1. It allows you to, but it's done in such a way that function, instead of returning a result, it returns another function with a smaller arity. It's super easy to create and is much easier to understand if you see an example. So you can do this in a super easy way because there's an instance method called carried. And as you can see, when you do this, suddenly our new function, our new result function is of arity of 1, and it returns another function this time, and not a result. So what does it give us? Sometimes it makes super easy to apply partial application. So suddenly, let's say here we had a function that was representing summing of 2 elements. But by transferring this, converting into a carried version, now it's super easy to apply partial application and pretty much fix one of the parameters over there. So now, if we take a carried version and calculate a value, we get another function. But this time, in this particular context, this function will not be a sum anyway. Well, it won't be a sum of 2 parameters, it will be a sum of 1 parameter, which is basically, in this case, it means there is a function that always adds a 2 to your result. So if you are abstracting out some more complicated stuff, you can use this form of functions for easy partial application. And here comes the fun part about memoization. So a few minutes ago, we talked about immutability, referential transparency. And so if we know that basically we are operating on something that's referential transparent, we can, after calling a function and getting a result, we basically know that this result will never change. So why bother with recalculating the value all the times if we know it will be always the same? So we can pretty much just cache the results and always just keep returning values from cache. And this is what memoization is about. After you evaluate certain function or expression for given parameters, let's cache those results, and each time in the future, just return them from cache. And this is what memoization is doing. So if you want to convert your function into a memoized version, of course it's super easy. You have an instance method, memoized, you just call it, and as you can see, the type is totally the same as in the past. So only the implementation changes. So let's have a look at a simple example. Well, example is very bad actually, but it shows how it works in a very good way. So let's create a function of math random. Okay, random is totally opposite of something that we would consider referential transparent. Okay, because we expect it to return a different value each time. So let's break it. Okay, so we can create a memoized version of random, and what's happening over there is we call it first time. And after getting the first value, it gets stored in a cache. So when we call apply again and call the function again, the value gets returned from a cache. And in this result, we are breaking the random function and basically making it a function that always returns the same value from cache. Okay, so that will be all for functional interfaces. Let's go to tuples. Tuples is something that you can consider like an anonymous object. Okay, it's like a special way that allows us to group some objects together in situations that doesn't really, well, you might think that some situations don't really deserve new class to be created, only, for example, to storing 2 values together. So you can do this in a super easy way with tuples. Of course, it follows the conventions used in Javaslang. So if you want to create a new object, you're using of method, and here it is. Well, obviously it's immutable as everything in Javaslang, and it has also much more available nice methods for interacting with it. So, for example, you have method map. No, you probably know this from optionals and streams from Java 8 or from other functional languages. So it all follows the same convention. You can provide here functions that will map the values that are inside. Obviously, there are additional methods like transform that allows you to basically take all values inside and calculate another value. Well, and stuff even like converting the whole the whole tuple into a sequence, iterable. Another one of the most, well, I would say the most important building block of the whole Javaslang is a mighty value, which represents a pure value that can't change its state. In Javaslang, you have also option, which is a value. We have try, lazy, and either future validation. And what's super important, so what's super nice about it, that if you traverse the code type hierarchy, you will notice that all the value interface at some point extends an iterable. This is super super handy in some situations, because basically all of those containers like option can have something inside or not. Try can be successful or not. Lazy can be initialized or not. Future can have already value or not. Validation can be validated or not. Everything have those two states, and those can be considered iterables. Okay, then consider collections of max of one element. And what's super nice is that the whole classes from collections API, they are values too, which means that of course they are immutable and they extend iterable. So we already know that this is the point. This is how you can mix it with normal collections API, because this is the only common denominator that you have between Javaslang and collections API, the iterable. So let's have a look at some examples. This one is probably, well, will be quite boring for you, because most of you probably already know optionals from Java 8. But just to refresh how it works, you put some value inside optional, you put it in this computational context of nullability or not, and now you can declaratively provide functions to option that will be performed, that signify some actions that will be performed on values that are inside. And at the end, we can just handle a situation where when it turns out that nothing is inside. Well, so far so good. It looks just like in Java 8, but there are some situations like, have you ever tried to filter the list of optionals and try to find only those present values? Well, this is how you do it. You need to type list.stream, then filter out and find only values that are the only optionals that are present. Well, you can't extract it in one run, so I need to add another map call and now extract explicitly value from an optional, well, and then collect. Well, it's not that bad, but I always had a feeling that there should be like an easier way for doing this, okay? So in Javaslang, you can here you can benefit from the fact that option is an iterable, because when you are applying flat map in the context of streams, it accepts another sequence of elements, okay? So for example, if we have lists of lists, we can flatten the structure using a flat map method. And this is what's happening here, because we are treating an optional as an iterable in this context. We are treating it as a container which is empty or not. So when we have a list of optionals, when calling flat map now, we are basically just collapsing the whole structure where empty optionals become nothing, and optionals that have something inside, they become only the single value. So as you can see, this is super easy. Also, and I was giving this talk like few months ago, and someone noticed that this is flat map all recently, and I can't unsee it with two eyes over there. Okay, yeah, you saw this. Okay, so try is another concept quite similar to an optional. In optionals, we're dealing with nullability, but in try, we are dealing with exceptions. So what we are putting inside the try is something that can produce an exception and handle this in a nice and in declarative way. So for example, if you have, well, let's create a new URI. The URIs, they love throwing different kind of exceptions. So we are throwing the whole call inside and wrapping it in a try. Then we can use this very similar APIs, okay? So we have in stream and optionals. You can also use map methods for telling declaratively what should be done with the result of that operation. And then in the last line, we can specify the handle a situation where something bad happened and exception appeared. Another nice thing to have is a lazy. The API is similar, as you can guess. It all follows the same convention. So what it is a way of representing lazy computations. And also, this is super nice because you can be lazy, and now you can pretty much operate on it using the same map filter methods. So what's happening over there? We have lazy off, and VLC, it's not a video player, it's just a very long computation, okay? And in this case, we are creating lazy of the result of VLC method, and then calling object to string and string to uppercase. What's super important now is that we defined, like, we expressed our will. We expressed our will, what do we want to do with the result of the operation. We want to toString it and then to uppercase it. But everything will be performed when we actually try to reach the value by performing a get method. Well, so we are coming to functional data structures. Well, functional data structures, well, if you went to Oleg's talk, you know that they are persistent and immutable, and I also keep adding that they have referential transparent methods to, like, just to remind viewers. Of course, this is super big topic, and if you can just revise Oleg's talk. But the whole idea over there is that, well, it's quite easy to create something immutable, but it's very hard to create something that's efficient. Because imagine a situation that if you are just copying in a very simple way, you have a list. You need to add element, and you can't modify it. You need to create a new version of it. And so you are just copying the previous one with a new one. What if you want to add the 1,000 elements? Okay, you just keep creating another elements infinitely, and this is problematic. Well, so this is where functional data structures came into play. Persistent collections. So they are not only immutable, but they are designed in a special way, in such a way that you are reusing the previous versions of those created lists. So in this case, they are created in such a way that the single list is created of a head element and another list recursively, okay? So when you're creating new versions of a list by adding elements, they're all immutable, but they reuse the previous versions. So if you have a list of one element and you want another one, you add element, and the new element becomes the head of the new list, and the previous list becomes the tail. And basically, in this way, all structures are implemented, and it allows saving us a lot of memory. Actually, there are not only lists. Okay, we have sets, maps, queues. It gets a little bit more complex in these situations because it's not that easy to implement this. So usually, like queues, you can implement using different combinations of lists. Well, just see Oleg's talk. So basically, if you look at the whole type hierarchy of Javaslang collections API, you will see a lot of familiar elements. You will see something like array, char sequence, vector, stack, list, stream, queue. Wait. But stream, let's focus on this one for a second, because stream in Java 8 is basically a fancy form of iterator that allows you to perform computations in a nice and declarative manner. But in Javaslang, this is not an iterator. This is a full normal collections. The problem with Java is that those streams were non-reusable, so they could be called only once. And if you try to call them again, there was an exception. So here the problem doesn't exist. It's a normal collection. In Java 8, they were forced to implement this like this to not break the whole collections API. Well, actually, honestly, I like the solution because this is what they could do with trying to force backward compatibility. And this is the most coolest part. I hope you can see this. When I first time played with Java 8 streams, I used my IDE, control space, and I saw a lot of methods. I was overwhelmed a lot. But after some times, I started noticing that some methods are missing there. Well, have you ever missed any method from Stream API, guys? Hmm? Okay. For me, well, there's only one person said something, so I guess that everyone else is just pretty much got everything they needed in Stream API. So for example, for me, there was something like zip missing, okay? Something that tools that allow you to like zip two streams together and create pairs. Or for example, something super easy like distinct by, but not using equals or hash code, but some externally provided comparator. But here in Javaslang, it becomes overwhelming again, because if you open your IDE and see all those methods, you have so many new methods like append self. Okay, you can return the head, you can return the last element, you can return them as options. Of course, you can zip with many different ways. You have distinct and also distinct by, where you can provide a custom comparator. Well, and you have even such fancy methods as combinations that returns a collection of all possible combinations of elements that are stored in a stream. Well, in Java 8, those are only streams that had such a nice and fancy API. But in Javaslang, it applies to basically all types in collections API. So as you can see, it's pretty universal and pretty cool. So you can even amaze your friends, well, or scare them by implementing stuff like this. Believe me, it works. It's a Fibonacci sequence implemented in like purely functional way. Don't ask me to explain this. Okay, so let's get back to the most interesting thing, the pattern matching that was implemented in Javaslang. Unfortunately, of course, it's not done on the language level, okay? We can't change this. Well, sometimes we can, but no, we don't want to include this in our libraries. But so it was implemented using basically having many static methods, and it works. Well, it doesn't work as well as this one in Scala or in Haskell, but still it's usable in like simple everyday use cases. So what pattern matching is, just in case. Pattern matching is like a very fancy way of having a switch case. You are matching some values against different cases. What's super nice that switch case in Java is pretty limited, but pattern matching are usually super powerful because you perform matchings using multiple ways. So as you can see here, it's a very simple case where we have basically cases where you provide predicates, and if the matched value matches, the associated value is returned. So for example, if our I integer is even, it falls into the first case, the even string is returned. If it's not, it's odd. Well, and if there is any other possibility, there you have a question mark. Obviously, sometimes you have situations where you don't want to match everything. So here you have another option. Well, another option, which is an option method too. So if you don't want to like close all possibilities using cases, you can always use option. But in this case, you will instead of a return value, you will get an option. So if there was any case that was matched, you will have an optional with something inside, and if there wasn't, you get empty one. Of course, you are not limited to using predicates as cases. Obviously, you can perform matchings by providing the values. So of course, you can match them. You can mix those approaches. You can create you can use predicates in some cases, and in another you can use simple values. But what's super cool actually about pattern matching is that it can be structural. What does it mean? Well, in the previous example, we basically provided it with simple values, okay? But the fun thing is that you can go deeper with those matchings. So as you can see here, we created a set of cases, but now we are performing matchings. In the second line, in the second case, you can see that we have a local date that matches 2016 here, and you have those $signs, which are basically wildcards. So what it means, in this case, all local dates of 2016 will fall into. And now you can basically access extract this value that was a month and a day and do something with it. So it's super nice. You can perform matchings on a structural level. Unfortunately, it doesn't it doesn't work recursively. Actually, at some point it was implemented. Daniel Dietrich said that when he implemented this, unfortunately, it worked with a small amount of parameters. But if you had more parameters, basically the code generator would generate so many possible cases, so many methods that would just abuse all possible physical like JVM limitations when it comes to like having a amount of methods in one class. So yeah, this works in Javaslang only on one level. And if you want to use this with your custom types, you need to unfortunately generate a little bit of code so that it's possible. So yeah, most of us won't do this if you need to include another dependency and generate code. So what's super nice is that all those things like option tries, those are basically abstract classes which have subtypes, and you can perform matching using those subtypes. So in this case, we are matching an optional, but we know that optional can be some with something inside or none with nothing. So in the first line over there, we are matching an optional that has something inside. We are putting this wildcard over there and extracting this value and using it for calculating the result. In the second one, obviously there's nothing to calculate. So we are returning a string. Also, what's super nice is that when you want to use predicates in your cases, well, there are multiple situations where you would keep reinventing a wheel. So Javaslang comes with many predefined predicates that can be used out of the box, and those cases become suddenly much more readable when you just use them. As you can see, you have methods like is in, any of, none of, instance of, is null, non-null. Well, it didn't include them here. Here you can see how it could look like in a real-life situation. For example, let's say that you are parsing command line parameters, and if you have, let's say, help or -h, like display help, and the second one I have -v or version, and in this case display version. And if you didn't if you didn't recognize what's in there, just run nothing in this case. What's also super nice is that you are not limited to using pattern matching in a like standalone way. It blends pretty nicely with all other tools that you got there. So, for example, why not use try? Why not use pattern matching instead of try or optional in a map or recover call, and make different cases for different types of exceptions that we got? It's super powerful in this case. So basically, this is how the high-level overview of Javaslang looks like. Of course, there's much more stuff into this. There are different additional modules. There's a circuit breaker. This is actually not a part of Javaslang anymore. You have another module for Jackson. You have special module for property testing. You have also Javaslang match, which this is the dependency that allows you to generate your own classes that can be used in pattern matching. So I hope that I got you interested into this. I noticed that the whole Vox Days tree is a lot of like functional oriented. So I think that if you want to start playing with functional code, probably Stream API optionals and Javaslang is a great place to start with, because you don't need to basically fight with a new syntax, but you can just use you can stay home in Java and try to learn those new tools one by one. So thank you very much. I hope you enjoyed Javaslang. Do you have any questions? A microphone is going to you, I think.
Thank you for the talk. It looks very much like Scala, so I was wondering, why don't you just use Scala?
First thing, yeah, of course it's officially inspired by Scala. Well, the answer is pretty easy. Well, I don't know, at least in Poland and in many situations. Well, imagine a situation where you are in a project that goes on for 7 years for banking or for insurance, and you go to your CEO boss and say, "Dude, you know what? Just throw away this Java 5 and write Clojure or Haskell." Okay? In many cases, it just doesn't work like this. At least a few years ago in Poland, it was very hard to find a real project where you could use Scala. Well, now it's pretty common, but a few years ago it was a problem. But still, if you're working somewhere and probably you haven't already changed to Scala because of some problems, because there are some limitations, business limitations. This is the nice and easy way of making your Java work much easier.
Do you have something for data structures? So I can, let's say, concat to data structures in a safe manner, like using pattern matching.
Can you rephrase your question? I mean,
for instance, I may have in other languages semigroups. Let's say JSON and method concat. How to combine with different JSON.
No, unfortunately, those are just simple collections. You don't have stuff like this here, unfortunately.
Do you have experience with integrating Javaslang in existing projects with Java?
Yes, basically.
Collection will break your code.
Yeah, I mean, I've been working on one project where we had we're mixing Javaslang with Java a lot. Yeah, and it was problematic. We had Hibernate over there, and it was really hard to force it to work with. We had Hibernate and Spring Web. And Spring Data. It was quite hard to make it work all together. Now there is some integration with Spring Data, which makes it a little bit easier. But unfortunately, yes, we had places in our code where we needed to stick to pure Java, and some places where we stick to Javaslang. It was very hard to integrate them together, because what it would essentially mean is to pretty much repackage one to another both ways. It didn't make much sense. We were lucky because Stream API was enough for our situation. Most cases, 80% of cases was simple mappings and filterings and recollecting stuff. But still, when we wanted to do a little bit more complex calculations, we still could pretty much encapsulate this, okay, and perform calculations using Javaslang if there were some methods that would be beneficial for us. And then perform repackaging. But yeah, we used functional interfaces, we used Tuples, we used collections API in small contexts where basically we were for calculating stuff, but not using Javaslang in APIs because it would be unhandy in many situations. But I was working in a project where we were doing this from a start. It was like a document scanner, and we managed to implement everything using Javaslang, and it worked super nice. For example, we had such a nice thing like generation of infinite sequences of images that would be rotated a bit for just fine-tuning the reading OCRs, and it worked pretty fine. Now I'm working in a Kotlin project, and honestly, we didn't use Javaslang because when you have Kotlin, you have a set of new collections over there, and you have optional types built into the language syntax. And that could be, again, problematic at some point. So this is how it looks like. So I have three situations. One project where we decided to not use Javaslang, one where we adopted but carefully, and one where we used it fully and it worked nice.
When you compare...
I don't see who is speaking.
Yeah, I'm here.
Okay.
When you compare the standard collections API to Javaslang, what's your experience regarding performance and memory consumption in real life projects?
In real life projects, those projects we're working with, the performance were we couldn't feel any difference, okay, because the real cases were like we're working on hundreds or thousands of elements, and this we couldn't really feel any impact. But obviously, when you use Javaslang, there is some impact, okay? Because when you use Java API, it's mutable and it's non-thread safe, okay? But when you compare it to Javaslang, Javaslang is slower, okay? It can be on average 2 to 4 times slower, but it's thread safe totally, okay? And just like Oleg Shalayev said today, it's all about, there's always some trade-off, okay? You get thread safety, but it's slightly slower, okay? So probably if you really want to fine-tune an application, you might want to consider using normal Java classes, especially when you know that there's only one thread jumping in there. So basically, I never experienced any problems with performance, but obviously there is an impact. If you want to see like really good comparison, there is micro benchmarking build task embedded into a Maven POM in the project. You can call it and see by yourself comparison against Scala Z, and some other stuff. What's interesting is that those collections are quite faster than what you can find in Scala Z. In the worst case, it's like 10 times faster, like when in the priority queue example, I think. Does this help? Okay. Thank you a lot.